Dear students, welcome to another lecture in Industrial Engineering and Quality Control. Yesterday we discussed about the 200 process chart, and there are some points which you should keep in mind about the 200 process chart. See, this chart is generally used for repetitive operations. That means you keep on doing the operations in cycles. You work upon one thing and you put it aside, you take another thing, you work upon it, put it aside, like that. Okay, when one cycle of the work is to be recorded, is it mostly like in a kind of mass production or something, and where the workers are involved, the same set of symbols are used. You see, the symbols that we were using, like the circle for operations, and for storage, a triangle, and capital D for delay, and arrow for transport, and square for inspection. Those things, the same set of symbols are used in 200 process chart except the inspection symbol. See, all the other symbols are used here, but the inspection symbol is not used here. But there is a reason why we don't use the inspection symbol in 200 process chart. The symbol for inspection is not used here. The reason is given in this paragraph. It is because now in the 200 process chart, what are we doing? We are recording the activities of the two hands. Okay, so inspection is not used. Why? Because the movements of the hands, when an operator is inspecting an article, it is classified as an operation because the hands are doing the work and not as not an inspection. Okay, even when it is being inspected, it is an activity for the hand. Okay, like that. Therefore, as an inspection symbol is not used. That square is not used. Okay, this you should keep in mind. Okay, then while you are preparing this 200 process chart, you see, you should study the cycle of operations for a few times and then start recording. You should not start at the moment you come to the place. You should not start recording. You observe it for some times and a certain number of cycles, and then afterwards, when you have understood what is the cycle, from where to where you should record. When you have understood that, then you should start recording. And the charting of one hand should be done at a time. You see, in two hands, if the operator is working with both hands, you see, simultaneously, it won't be convenient to concentrate upon both the hands. So therefore, it is better to concentrate on one hand, and it should be charted out, and then afterwards you focus on the other hand and again you chart it out. Okay, that way you will be able to, it is not that you only one cycle you will be able to record everything in number of cycles, because it is a repetitive action. The operator is doing the same work again and again. So you should first concentrate on one hand, and then next. Then activities which occur in sequence. Sequence means what? One after the other. If they're occurring in sequence, they should be recorded on the chart at different horizontal levels. See, if left hand and right hand in the same horizontal level, something you are writing means what? Both are taking place at the same time. But now these activities which are in sequence, that means one after the other, that means it should not be in the horizontal level. It should be one below the other. That means in a different horizontal levels you should draw. And another point is, care must be taken to list everything that the operator does. You should not omit anything. You should observe everything, and to avoid combining operations, and transports or positionings, this also you should avoid. What you should avoid? You should avoid combining the operations unless they are actually occurring at the same time. You see, sometimes we have they may be doing one after the other, but we think no, that they both are done at the same time, and let us do combining of the operations. Such things, such thing should be avoided. Okay. Now, let us go to the next one. Now, next chart that we are going to discuss is multiple activity chart. Okay, multiple means more than one. Okay, one you can say. Okay, one, more than two, like that, more than one. A multiple activity chart is defined. Here is the definition given in this paragraph. The multiple activity chart is defined as a chart on which the activities of more than one subject are recorded on a common time scale. Here there is a common time scale. Okay, they are recorded on a common time scale to show their interrelationship. Now these activities are being performed, see, by more than one subject. Okay, in this definition, subject means what? This subject can be a worker or a machine. Okay, so in the multiple activity chart, the multiple activity chart is used when a number of workers work in group. You see, it can be happen no, one worker is attending to one machine. It is possible. Okay, or a number of workers are working in group, or an individual operator is handling two machines or more than two machines. You see, one machine, one operator, one machine, more than one operator. Okay, or one machine, one man and two machines. Okay, one man and many machines. All these things are possible. Okay, the multiple activity chart is made to detect idle time enforced on men and machines. See, we are studying the method, to improve it. So here, by charting out this multiple activity chart, we will be able to detect idle time. Is there any time idle? The machine also is idle, man also is idle, or any of the idle times can be eliminated, thereby reducing the time. To study that, we are using multiple activity chart. This gives us a better understanding of the various activities that these men and machines are doing, and we will be able to properly sequence them in such a way that the time is reduced. Okay, it also establishes a number of machines that can be conveniently handled by an operator. You see, if suppose if you load a machine, the workpiece is loaded onto the machine. Now the machine starts working. It can be a semi-automatic machine or fully automatic machine. You see, in such cases, what the operator will be simply sitting idle. So at that time, can he operate some other machine? Can he operate two machines? Can he operate more than two machines? All those things, we will be able to have an idea by looking at this multiple activity chart. And if he can attend to more than one machine, then how many machines can he attend? Okay. It also determines the number of workers necessary to perform a job involving a teamwork. Suppose in a team they have to work, then what will be the number of workers required? Whether 2 people are needed, 3 people are needed, or more than that are needed. We will be able to determine with the help of this chart. It helps to develop an improved method of accomplishing a task and to have an effective labor cost control. So that's what we are saying. We will be able to arrive at an improved method. when we are saying improved method, most probably it is one which is consuming less time. Okay. In making a chart, the activities of different operations or of the different machines are recorded in terms of working time and idle time. You see, if you take one man and one machine, for example, you see, when a man is loading the machine will be idle. Okay, when the machine starts working, maybe the man will be idle unless he has some other work to do. Okay, or bringing some other workpiece nearer to the machine and other things. You see, there will be working time and idle time. These are the two things. The times may be recorded by stopwatch, and the times are then plotted in their respective columns. So when we see an example, you will be able to understand how these columns are charted. Okay, see, when we talk about multiple activity chart, the types of multiple activity chart, you see here are listed four different types of multiple activity chart. Okay, man machine chart. In this, one man handles one machine. Okay, or one job. Okay, this is called man machine chart. See, man multi machine chart. That means one man is there, but machines are multi. That is more than one machine is there. So that is man multi machine chart. Then multi man chart. It shows a group of workers doing collectively one job or operating one machine, like riveting, construction work and such things. Okay, that is multi-man chart. And the fourth one is multi-man machine chart. Here a number of persons are working on number of machines. That is the meaning here. Okay, so these are different types of multiple activity chart. Okay, now let us come to the construction of multiple activity chart. A multiple activity chart, it consists of series of bars placed against a common time scale. You see, here there is a common time scale. You see, when you want to with a stopwatch you are recording, that means even seconds you are recording. Okay, so at that time a time scale should be there. So there is a common time scale on the basis of which the activities of man as well as the machine are recorded. See, one separate bar is provided for each object. If only one man is there, one bar will be there. If one machine is there, one bar. One man, one machine means two bars will be there. If one man and two machines are there, then three bars, because one for man and two for two different machines. Okay, and activities related to the subjects are represented in the bar. Okay, the columns are placed against a common time scale. Again, this common time scale here also we are coming across this phrase common time scale, which starts with 0 and terminates at cycle time of the job. You see, all the times we set to 0 and start recording. We initially determine what is the cycle, from where we should start and till where we should record. Okay, that is a cycle. And how much, so that means what? It starts at 0 and terminates at the cycle time of the job. Okay, the task to be recorded is broken into smaller activities, and time for each activity is provided by a previously conducted time study. We keep on doing time study for various things, so various activities. So if you break any of the task into smaller activities, then these smaller activities we will be able to say how much this small activity, how much time that small activity should take. Okay, so if you break it into small activities, then you'll be able to say, and thereby you can see whether any time can be saved. Then working and idle time along with the activity are marked on the chart. So that's what, these are the two things that we are going to mark. Is a when is the man working and when is he idle, when is a machine working and when it is idle. Okay, that's how it is. See, therefore, the two symbols are used in making of this chart. One is representing working time. You see, if you hash it like this, hatching, if you are hatching it like this, then it represents working. If it is blank white like this, that means it is idle. Okay, one is representing working time by cross lines or hatching, you can say, and other is representing the idle time by a blank bar. That is, it is unshaded. This is shaded, this is unshaded, you can say. These are the two symbols which we are going to use in the multiple activity chart. Okay, now let us see an example here. This is an example of multiple activity chart. Okay, so in all the activities, on at the top, or the heading, some details are to be given. See, one thing we should clearly specify is whether it is a present method or proposed method. That means whether it is an old method or whether it is a new method. You see, for both of those things we have to prepare the multiple activity chart, and thereby we should be able to compare. You see, old method was taking so much time, whereas in new method we have saved so much time. That's how you have to present it. Okay, therefore you should clearly mention whether it is present method or proposed method. Okay, now this is the cycle's task. What is the task? It is machining of a compound. You see, here they said machining. What type of machining is not mentioned, because this is just for an example. They simply said machining. Machining can be on a milling machine, or a drilling machine, or a lathe machine, or any other grinding machine, or any such thing. Machining can be done on a component. And what type of component also, it is not clearly specified. Okay, now again, normally you see these two things also, where chart begins and where it ends. You see, here the chart is beginning where the part to be machined is lying near the machine. See, near the machine this part is lying. See, there we will start. Okay, and then where is the chart ending? Chart is ending after the part is machined and it is laid in a container. Okay, then you can have charted by, that means who has prepared this chart, and what is the charting date. Or you can also have checked by, that means supervisor will be signing above, and that means the person who is supervising this person who is charting. Okay, so these are some of the things on the top of the chart we should write without forgetting. This is in your books you may not be having these things, but if it is if you are in the exam when you write the answers, so the examiner will be expecting you to write these things. It may make just a 1 mark difference between a person who writes this and who doesn't. Okay, now let us see. See, this is the chart. Okay, now we have one operator and one machine. Okay, you see here the first column gives some values which appear to be like a timing, and these timings appear to be cumulative timings. So cumulative means what? You keep adding. Okay, so the second column we have an operator and what operator is doing, his activities, the description of the activities performed by the operator. And in the third column what you are having is T, that is, these are the you can say times that are the first column is a cumulative time. This is not cumulative, this is the time each activity is taking. Okay, and the fourth column, the symbol S is written. This is for the symbols. You see, you're using two symbols. You see, these are the two symbols that you are using, one for work. So two symbols you are using, one for working and one for idle. So you see here a shaded portion is working time, and blank white space is for idle time. Okay, so you see, you leave the first column is only for cumulative times, second, third and fourth, these are for the operator, and this fifth, sixth, seventh, these are for the machine. Again, as you had the operator's activities description, time and symbol, for similarly for machine also, machine's activity description, time and symbol. Okay, like that you have so many columns. Now how many columns are there? You see, 3 for each, total 6, and plus the cumulative timing column, that is the seventh one. Okay, now let us see what is the task that is allotted to us. Machining of a compound. You see, and that part is lying near, to be machined, and it is lying near the machine. Okay, now we start with 0 time. Now, okay, and first, what you have to do, you have to take the part that is lying near the machine, and you have to load the machine. So this is the loading the job on the machine. So, and this takes 0.2 minutes. These timings are all in minutes. Okay, 0.2 minutes. At that time, this is an activity, so it is shaded here. And what is the machine doing? Machine is idle, so no time for it and no symbol for it. No symbol means the white symbol. Okay, now come to the second activities of the operator. Now he will switch on the machine. You see, for loading he took 0.2 minutes, and for switching it on, he just takes 0.08 minutes. So if you come here, the cumulative time will be, if you started with 0, initially you came to 0.20, and next, by the time he switched on the machine, the cumulative time came to 0.28 minutes. Okay, and this is also to be shaded, and at that time machine is idle, and here all blanks. Okay, then next activity. Next activity is again switch on. What is he switching on now? Switching on. Okay, you can say first is switching on the machine, you can say. The second is you're switching on the coolant, you can say. Okay, or first you have switched on the coolant, second you have switched on the machine. Okay, this also takes 0.8 minutes, and this is also activity for the operator and idle for the machine. And afterwards, then once you switched it on, you see, first, here if when you switch it on, it should be coolant, and here the machine, because as soon as you switch on the machine starts its cycle. It may be an automatic or semi-automatic machine. So semi-automatic machine, it machines the part, and for machining it is taking 1.5 minutes, and therefore here it is doing the operation, and therefore we have shaded here. And once this machining is done and it is stopped, what you have to do now, you have to unload the part, or you have to pick up the part, which you may just take 0.05 minutes. Okay, now all these are cumulatively added. See, 0.2, see, 0 plus 0.2 is 0.2, and 0.2 plus 0.08 is 0.28, 0.28 plus 0.08 is 0.36, and 0.36 and 1.5 is 1.86, and 1.86 plus 0.05 is 1.91, and 1.91 plus 0.5 is 1.96. This is the total cycle time. So finally what you did, you unloaded the part and you kept it in the tray. Okay, at that time also these are idle. Okay, see, this is the proposed method. So is there any way he can reduce this, that's what we have to see. Okay, that see, we are not now trying to reduce the time or something. Now what, at this stage, what we are learning is how to record only the recording of different the recording in different charts. That's what we are learning. So how this chart is prepared. Okay, now this is the summary here. The operator cycle time is 1.6, the machine time also is 1.96, and machine time also is 1.96 minutes, and time worked per cycle. You see here, the man is working only here for 1.5 minutes. He didn't work, so total time worked for man is only 0.46. Okay, whereas for machine it is 1.5, where so that means what, man has worked only for 23.4 minutes, 4% of the time, whereas machine worked for 76.6% of the time. Okay, so here these people are this man is free for almost 77% of the time. At that time, no, this man can be made to operate some other machine. Okay, there also, if some other machine also, these cycle times can be staggered a little, so that he can attend this also and start it and go in this 1.5 minutes gap he is getting. He can attend to the other machine and start it and again come back here. Okay, like that he can attend to two machines. Now that way, with the help of the multiple activity chart, we can put the operator, you can utilize his man hours in a better way. Okay, so coming to the next thing, now we will see what is the purpose of the multiple activity chart. Multiple activity chart, this is used for detecting the idle time. It can be of the machine's idle time or the worker's idle time. Okay, and then another purpose of multiple activity chart is to optimize the work distribution between workers and the machines. See, now just now, as I said, a worker can be made to attend to two machines. That means what, we have optimized his activities. Okay, that way you can, with the help of multiple activity chart, you can optimize the distribution between workers and machines. And to decide the number of workers in a group, if it is a group activity and many workers are working, so you can, how many workers should be allotted this work, with the help of multiple activity chart, you will be able to come to a conclusion. Then to balance the work team, okay, the team also, if you want to balance it, in the team, the men also, and to them some machines also you can give, and you can balance them. And then to examine the activities of workers, or the activities of the machines. It is used for recording the complex movements of material or men, and it is used to find out most economical route also. Yeah, okay. Yeah, you can eliminate some of the circuitous routes, the raw materials or semi-finished goods are coming, if it is taking more time and all. Okay, because we are tracking the activities of man also. Okay, so with this we finish this multiple activity chart. Now let us move to the next thing, that is flow diagram. See, this is flow diagram. It is defined as a scaled diagram. See, sometimes they may ask you which of the things is scaled diagram. Scaled means actually, how your shop floor is, how many feet by how many feet, like a scaled diagram you draw this. That's why this phrase, a scaled diagram, is important. It is defined as a scaled diagram which shows relative position of the machines, inspection section, stores, work, the paths followed by men and materials. All these things, where the machines are, where the inspection section is, where the stores are, where the work and its paths are paths followed by the men materials are. These are the things we should sketch it clearly. And there is a disadvantage of a flow process chart, that it does not indicate the actual movement of the men and materials. So some of the assumptions they may be making, because of which the actual movements are not recorded. That is one of the disadvantages. Okay, then next point is, it is important because if the number of movements is minimized, it results in a lot of saving in time and ultimately cost. You see, if you study the flow diagram properly, and you are able to minimize the movements of the workers or the material, there what will you do is, you will be able to save a lot of time. And when you are saving a lot of time, that means you are ultimately saving the cost. Okay, cost of manufacturing of that product. Okay, next point is, the path of movement and frequency of movement can be better utilized by a flow diagram. See, when we see how it looks, you may be able to appreciate in a better way. The path of movement and the frequency of movement can be better utilized by a flow diagram. Okay, next let us see. This is how a flow diagram looks. Okay, see here, a store is there. This is a scaled diagram, scaled diagram. That means the length of it and the breadth of it, these are according to some proportion, with the help of scale, as we draw on the drawing sheet. These are made. Okay, so thereby you will be if you know the distance from here to here, the scale also, and multiply by this scale factor, you'll be able to find out the exact distance between these 2 points. Okay, so here there is a store, here there may be some machine, here another machine, here another machine, here this is a inspection section. Why? Because I can see a square here. Okay, square is for inspection, and here it is kept for temporarily for some time, because it is showing delay, and afterwards finally it is moving like this. You see, these are the movements, transport, you can see. Okay, you see, now let us see what are the steps in drawing. Steps in drawing the flow diagram are given below. Draw the plan of work area to the scale. Plan, this is what normally civil engineers will be using. Plan means, as you have studied in engineering drawing, the word plan means, top view. Now this is a top view of the room or the shed where all our activities are taking place. Okay, this is the plan. Draw the plan of the work area to the scale. This is important, to the scale. Okay, then mark the relative positions of machines, stores, inspection section, etc. See, here the store, here these three are machines, here is the inspection section, and here it is a temporary storage. All these things, relative positions, you mark them. Then draw the path followed by men or material on the diagram. You see, this is the path, as you can see here, from the store it started, and this is the first transport, this is the first operation, this is the second transport, second operation, third transport, third operation, fourth transport, first inspection, fifth transport, first delay, and then sixth transport. You see, this is the path. Okay, indicate the direction of movement on the path. Then use appropriate process symbols on the diagram. See, these are the appropriate symbols. These triangles, arrow, circle, and square, and the capital D. These are the process chart symbols. on these are the appropriate symbols we used, and use the serial number to mark various symbols in sequence. You see, you see, because they have put 1 2 3 like that, then we know what is the how the workpiece is moving. Okay, so like that is how the flow of the workpiece is. A workpiece is taken, raw material is taken from the store and it is transported to the first machine. There some activity is carried out, and then it is transported as a semi-finished good to the second machine. There some other activity operation is done, some other machining is done, and then it is transported a semi-finished good to the third machine. There some other operation is done. Okay, now the only 3 machines and 3 operations are done. Now it is in finished condition, but it should be first inspected whether everything is right. Okay, well, various gauges, various quality checks you may be doing or the inspections section, and so once it is approved, then it is transported to the waiting area or the delay place, temporary storage, and from there finally it is moved to the shipping section, wherever that material should be sent, or you can again send to some other store. This is the raw material store, and here there can be a finished goods store. Okay, like that. Now coming to the next is, now we have finished the flow diagram. Now let us see the string diagram. A string diagram is defined as a scale plan. This is again a scale plan. Flow diagram also is a scale drawing, and this is also a scale drawing. Okay, a string diagram. String means what? Just a rope, a piece of string. Okay, a string diagram. स्ट्रिंग बोले तो दोरी, दोरी मराठी में. Okay, a string diagram is defined as a scale plan or a model on which a thread is used to trace and measure the path of workers, materials or equipment during a specified sequence of events. You see, here what we do is, as the man is moving from one place to another place, as we make a small model of it, small plan of it, and then we will be winding this this thread around it, this string around some this at different machines you may put some pins or something around that. You see how many times the man is going, so many times the string will be winding there. So okay, so it is a special form of flow diagram, because that is also scaled thing, this is also scaled. It is a special case, you can say like that, in which a string or thread is used to represent the movement. Okay, the purpose of using a string is to measure the distance between the two movements. What are we doing is, you are using a string to measure the distance between the two movements. You see how much a string is being consumed. On the basis of that, you will be able to say how much of travel is taking place. Okay, a repetitive movement and too many paths make the flow diagram congested and it becomes difficult to understand. This is one of the disadvantages of string diagram. You see, too many paths. If in one cycle and a person is moving many times there, so the string will be winding, and you will not even understand, like that. See, the paths which are traveled more frequently calls for critical examination of the work points or movements. Okay, if a lot of thread is wound in between 2 points, then that means we can give an attention to that. We can think, we can critically analyze it, because if you can bring those 2 points together, you will be able to save time. Okay, let us see. You see, this is how the thing is, the string diagram. The steps in drawing a string diagram are given below. You see, first draw the scale plan. like in flow diagram, here also you draw this scale plan. Okay, scale plan means it will not be as big as the shed, but it is a small model to the scale. Okay, like that. Then mark the relative positions of machines, stores, inspection section, etc. Here, instead of showing which is what, they have simply used A, B, C, D, E, F, G, H, I, J, like this, these letters they have used. Okay, we don't know which is store and which is machine, which is inspection section. Okay, then attach the complete plan of a soft wood or composition board, like notice board we have, in that we'll be inserting pins now. See, for that, that board should be soft wood. Okay, or a kind of thermocol or something backing they use. Normally, thermocol cannot stand for long, for many days, but soft wood you can use, so that your pin can be easily inserted. Okay, like that. Then fix the pins on the marked positions. Now here these are the pins. You see, this is A, here the pin for A is there. Here B, here the pin is there. C, the pin. D, a pin. E, a pin. And why pins are needed? Because you have to wind the string, the thread. Okay, so attach. Okay, fix the pins and on the marked positions, and at all the turning points on the route, here. Okay, here, all the pins are there where these stations are there. But sometimes there may not be a machine, but there, because your turning there is there you may put another pin also. Okay, tie the thread or string on the starting point of the movement and wound it to match the path followed by worker or materials. So you start where initially, as where they started in store or something, start, and then you keep winding, and you will understand where more string is being wound, and where more there is a chance for improvement. So here is an example of a string diagram, before and after. You see, it was initially like this. At the sheet metal, it started here, and it is taken here for checking and marking, and from here it is taken here for cutting, and from here it is taken for drilling, and from here it is brought here for folding of the machine metal. And here this is a little gone like this, because we cannot go straight, because in this cutting operators will be standing here and working, so we have to take a turning there, and then go to rivet section, rivet it, and from there again come to inspection table, inspection section, there check it again, and from there you take to the end point. So this was how it was initially before. Then after drawing it, and they found out why so much unnecessary movements are there, how it should be. It can be arranged in this fashion. First, the where the you can say this is a store where the sheet metal is taken, start here, and the marking and cutting can be placed together here, and from there drilling, then folding, and then riveting and inspection, and then again back to stacking or storing. Okay, so thereby this way you will be using less of the string, and thereby you will be saving time. Okay, so okay friends, I think we should stop here for today, and we will see again in the next lecture. Thank you.